Hey folks, this is Matthew Zachary, and before we get to the show, I wanted to tell you about another show from Offscript Media called The Cancer Mavericks. It's an 8-part deep dive narrative into the very story of cancer survivorship and the movement that started in the United States 50 years ago. This is not a podcast about the disease of cancer, it's a podcast about the people who made it better for all of us. Please search for The Cancer Mavericks wherever you listen to your podcasts and follow so you don't miss an episode. Thank you.
I'm soon going to be launching the Patients Getting Paid online course that will teach you how to get paid because of your illness, not despite it. Are you interested in doing patient advocacy work, but you don't know where to start? Want to learn about how to find online remote gigs or learn to create your own? I wish somebody would have created this roadmap for me. I spent a lot of time and energy and money figuring it all out. I want you to be able to leapfrog over all that stuff and get to the good stuff, getting paid for sharing your story. In my new course, Patients Getting Paid, I'll be sharing my experience and my resources on how to create an income online that lets me take good care of myself. Want to learn how I did it? Want a list of resources, places to look for online gigs, and templated emails with what to say? It's in there. Want to hear about tons of different ways you can actually build a business while taking better care of yourself? It's in there. Want to be included in a database of chronic illness warriors so your contact info can be shared when opportunities for your disease come my way? Then get on the waiting list for Patients Getting Paid and be the first to know when it launches. Sign up now at patientsgettingpaid.com/list. Welcome to the FUMS Now podcast show, where you'll gain information, inspiration, and motivation for living your best life with multiple sclerosis. Find us online at FUMSnow.com. I'm your host, Kathy Reagan Young. Hey everybody, thanks so much for hanging out with me again today. I'm excited for today's conversation about MS and bowel issues. A lot of people in our community are dealing with this, so I'm grateful to be able to bring some answers from an expert. But first, before I introduce today's guest, let me remind you to sign up for our weekly newsletter, the FUMS 6-Pack, where I share the top 6 topics in MS that week. Sign up at FUMSnow.com/getthescoop. And to go along with today's topic, please head over to the page that features my ebook, Bowel and Bladder Issues in MS by 2 pea-brains with potty mouths talking shit about MS. Lots of practical suggestions from a pelvic floor specialist and my best friend, Erin Glaze, and some kind of hopefully funny, smart-assy humor from me. So find that downloadable ebook at FUMSnow.com/ebook. So today's guest is Dr. David Levinthal. He is the director of the Gastroenterology Motility Center at the University of Pittsburgh Medical Center. He received his doctorate in neuroscience and medical degree at the University of Pittsburgh. He completed his residency at the University of Michigan Health System and came back to Pittsburgh for gastroenterology and postdoctoral fellowship training. Dr. Levinthal's clinical and research interests center on functional and motility disorders of the GI tract, as well as GI symptoms that arise in the context of neurological disorders such as ding-ding, multiple sclerosis, Parkinson's disease, and stroke or spinal injury. He conducts basic translational and clinical research bearing on interactions between the brain and the gut with the goal of developing brain-based therapies for chronic GI disorders. That is a mouthful and very impressive. Welcome, Dr. Levinthal.
Oh, thank you, Kathy, for inviting me. I'm really excited to be here today. Thank you.
Oh, I'm so pleased you're here. So let's start with something super basic. Came out of my super basic head, but what exactly is neurogastroenterology and how does that differ from gastroenterology?
Right. No, it's a great question. So, the field of gastroenterology is pretty broad, right? I mean, the GI tract includes the entire digestive tract, the liver, pancreas, other organs. So within the field broadly of GI, there's so many issues that can plague the GI system. cancers and so on. So one of the subspecialties of the field is really the focus on the squeezing action or the motility of the gut. And when you start to talk about the transit or the actions of the gut itself, there's a mini brain that's in the gut, and it's formed of nerves and neurotransmitters, and that receives instructions from the central nervous system. So this kind of brain-gut connection is embodied in the field of neurogastroenterology, which is really focused on the neural regulation of the GI tract's functions. So a neurogastroenterologist clinically focuses on disorders that are some aberration of the sensations that are felt from the gut, as well as the actions of the gut from a kind of a muscle standpoint. So that's
Gotcha.
kind of the field. Yeah.
Okay. Are there many of you? The reason I'm asking is I'm just wondering. Yeah, I'm wondering, for people listening, I'm sure a lot of people's ears are perking up and they're thinking, I've never heard of this, but how do I get to one?
Right. Well, I think this field, the evolution of gastroenterology has always included this issue. And it's really only in the last perhaps 30 years or so that there's been a kind of a subspecialization within GI. Mm-hmm. As technology moves along and certain types of tests, there's really been a movement to kind of consolidate some of the training and kind of saying, I am a neurogastroenterologist. So there is the American Neurogastroenterology and Motility Society, or ANMS, which is, I'm a counselor for that organization. And on a national level, there are a couple hundred people that would, I think, brand themselves as neurogastroenterologists. But this is, as I said, there's an increasing need because these disorders are not unusual at all. This includes functional GI disorders such as irritable bowel syndrome and other very chronic and common conditions. So obviously, we'll talk about MS, but a neurogastroenterologist really sees a whole range of patients that suffer with chronic digestive problems, and I think every neurogastroenterologist would have an enrichment for patients that have neurologic disorders such as MS or Parkinson's, maybe spinal injury, and so on. So, I hope that more people join the field.
Yeah, and I will just a note to everyone. I will put that link that you just mentioned in the show notes. So,
that'd be great. Thank you.
Yeah. Don't drive off the road if you're listening in your car. I got you. Okay. I got the notes. So why do people with MS have so many bowel issues? And do they in fact differ from the general population like we think they do?
Yes. So you're absolutely correct. So I mean, it is very common for, and then we have to be a little careful, right? So not everyone with MS has the same disorder, right? And I'm sure
the same anything,
right? So it's such a protein disorder, and I think all the caveats that I'm sure every guest and every discussion you've had with MS, it is not a monolith, right? But as a population, patients with MS, even in relative remission, likely have some GI disorders. I mean, it's a whole range. And why is that? It's a really good question, right? So we, first of all, there isn't enough research even to document what the prevalence of some gastrointestinal issues are in the MS population. Some very older literature. I actually was a part of a study that tried to get at that issue. So just to be kind of clear, so the most prevalent gastrointestinal issues with patients with MS, constipation, problems with bowel dysfunction, even fecal incontinence, those are not uncommon. Constipation may be about 40% of all patients with MS. And that would be about triple or maybe even 4 times the rate of constipation in the general population. So that's overrepresented in the MS population.
Yeah, we're overachievers.
Yeah, well, that's one way to achieve, right? So if you're going for fewer bowel movements, so that there's clearly this link between constipation being highly overrepresented. And then there's swallowing issues. And, if you think about it, the 2 major issues that are pelvic floor muscle related, we're going to get into the details perhaps, but, evacuation of stool requires muscle action. So it's not just the gut, right? So this is a place where the skeletal muscle system, motor system interacts with the GI tract. And it happens in 2 very major places when we swallow. So all of the muscles of our throat and the very refined timing of how we swallow even if that timing is off by milliseconds. There can be problems with dysphagia, which would be the medical term for trouble swallowing. And that's really actually a skeletal muscle issue. This is the entree of food into the GI tract. So that can be a problem, and that's not an uncommon problem. And then there's actually moving your bowels, which requires contracting your abdominal muscles to generate force to go. There's ultimately, physics to pooping, right? So things don't just come out, you need to push it out. So if you can't push, that in and of itself is a problem, much less the sphincter mechanisms of the anal canal and so on. So I think it can seem pretty clear that ingestion and defecation are the two hotspots of issues for patients with MS that are well above population prevalence of these issues. But there may be even more than that, and we can get into some of the other issues people have.
I was going to ask you about giving us a breakdown of the range of issues that you see, but it sounds like you just did that. So 40% constipation is kind of the most common.
Right. Yeah, there's an interesting subgroup. And I think there's one, we actually have a research that we're going to publish hopefully soon. That initial survey that we did many years ago and published in MS International was the journal. That was the 40% mark for constipation, but about a third of patients, maybe a 30%, had stomach problems too. Now, when I say stomach, I don't mean just abdominal discomfort. I mean, kind of referable symptoms to stomach issues, so feeling full easily when you eat, feeling bloated, not having as much of an appetite, having pain with eating. So that's kind of globally called dyspepsia. These are all medical terms, right? So the doctor would say, "Oh yeah, all of those things I just said, dyspepsia," almost like indigestion, right? So kind of a vague term. You can drill down on the specifics, but about 30% of MS patients had those symptoms, and we were trying to figure out what factors dictate if someone has that or not. That has not been typically appreciated. So I think our research kind of uncovered a little bit of more not maybe not hidden, but just an underappreciated range of GI symptoms that are there too.
Interesting. Yeah. So the gut-brain link seems to be kind of a buzz term these days. And you're doing some research in that, are you not?
Yes. No, so I wear several hats. Clinically, I'm the head of our Neurogastroenterology Center at the University of Pittsburgh Medical Center, but I also do research, and my background is as a neuroscientist. And one of the major questions that I have, and this is one aspect of this brain-gut connection, but it has been well appreciated for 100 years or more that our brain and our gut interact. And it's a two-way street. I mean, obviously, we come to some conscious perception of what happens in our gut. Hopefully not all the time, because there's a lot going on all the time, and we'd be flooded with sensation if it was.
We'd be distracted a lot.
We'd be distracted, right. So what happens in the gut should kind of be kept quiet. But it influences, fascinatingly, our perhaps how we feel and our mood and so on. So there's this big story about microbiome, the microbiota, the bacteria that live in the gut, how that may interact with the sensation nerves that ultimately color our brain's function. So I'll kind of get to that in a moment. The aspect that personally I'm the most interested in from a researcher is actually the other side of the coin, which is how does our brain influence the gut? So remember, it's a two-way street, brain to gut, as well, a gut to brain, as well as a brain to gut connection. So a big question is just how could our brain influence our gut? And so there are nerves that are influenced by our brain. One's called the vagus nerve, which is, I think your listeners may have heard. And another set of nerves called the sympathetic nerve. So these are two kind of aspects of what's called the autonomic nervous system. So nerves that we don't typically think about having to volitionally control, but nonetheless are always programming our body's state, our heart rate, our breathing rate, our gut's action. And so what the research that I've been involved in is trying to answer the question, how does the surface of the brain, the cortex, the cerebral cortex, which is really where our thoughts, our volition, our behavior kind of originates, what areas of the cerebral cortex influences the gut? And and if we understood that, could that link to how we know that how changes in how we think and how we feel and how we move influence the gut? Is that the substrate, like the neural connection? And so we've been able to do that, and I can you can tell me if you want to hear more, but we have a technique that we can map this. And that's kind of a foray to, if we know what's connected, then we can influence those connections.
So you have a technique that you can map for each person? Is that what you mean?
Right. Well, there's a couple ways we can do this. So this is animal research to begin with. The idea is that all mammals have some link between their brain and their gut. Pavlov showed 100 years ago that animals can change their gut function just with the appropriate cues. I mean, clearly this is a cognitive influence, right?
My mouth just watered when you said Pavlov.
Well, there you go. All right, sorry, I triggered you. But, Pavlov won the Nobel Prize for pancreatic physiology. It wasn't actually classical conditioning. It was like in the physiology experiments, they basically uncovered that this was important enough that it was a confounder. And then he was a good experimentalist, and they figured out, it actually matters who the experimenter is, smells, sights, all these things matter for GI physiology. It's one of the initial insights. So that's through the vagus nerve is a major nerve, and both nerves matter. So without going into too much detail, essentially the mapping procedure in animals, these were in rats. We're also doing this in non-human primates because we want to study a brain that's as close to a human brain as we can. We use a virus, rabies virus of all things, which I'm immune, so I can't get it. I've gotten my vaccination for rabies virus. But in an unvaccinated animal, rabies virus gets into the central nervous system because of a property of the virus itself. Anyway, you can use this neural tropic property of rabies virus to actually infect the nervous system. And when we inject it in an organ, like the stomach, the nerve endings that are there take up the virus and basically transport it to the brain. And it marches through a neural circuit. Anyway, we can use it as a circuit tracer. And that's the only important thing I think your audience needs to hear. And we can actually look at where those neurons are that got infected, and we can make a map of them. So essentially, we've been making maps of organs, the stomach, the colon, the adrenal gland, other organs, GI and non-GI organs. And what's emerged is there's some common sets of cortical areas that are linked to organ control. And the fascinating thing is, without getting into too much jargon, those areas are involved in how we think and how we feel and how we move. And so it really probably is the neural substrate of sorts of that top-down influence from the brain to the gut. So having that map gives us a handle on an idea of, is that present in humans? Probably is. And could we target that with either brain stimulation or some other way to actually influence gut function from the brain side? So I hope that kind of makes some sense. So
it does. Yeah, that makes a lot of sense. That's super interesting.
Thank you.
What's up, people? Matthew Zachary here. Let me talk to you about Unraveled, a brand new podcast from the Dana-Farber Cancer Institute that gives us hope about the progress of cancer research. And yes, believe it or not, there's actually been a ton of progress. I mean, who doesn't know someone affected by cancer or someone who's donated to cancer research? While that philanthropy is desperately needed, most people who give don't understand what's actually happening in the trenches of cancer research and the impact that has on all of us. It's time to go beyond the headlines with Unraveled. Listen to the stories of doctors, researchers, patients. Learn about the breakthrough science like using genetically engineered T cells to turn a patient's immune system into a cancer-fighting machine. Yes, that really happens. It's not science fiction. These are stories of the people who continue to fight for better research, better cures, and better care for patients, especially during the COVID-19 pandemic. Follow Unraveled from the Dana-Farber Cancer Institute on Apple Podcasts, Spotify, or wherever you listen to your podcasts.
Are you tired of wasting time making trips to the grocery store, waiting in checkout lines, and overpaying for groceries every week? We thought so. Luckily, there's a better way. Misfits Market takes the hassle out of grocery shopping by delivering fresh, organic produce and sustainable groceries straight to your home at prices up to 40% less than traditional grocery stores. You'll get access to exclusive weekly savings on peak season organic produce, high-quality meats and seafood, and sustainably sourced pantry staples like snacks, pasta, and grains, plus keto-friendly and gluten-free foods. Do your weekly shopping in just minutes with Misfits Market, all with no service fees, membership fees, or commitments. Become a free member today and get $15 off your first order through September 30th. Just go to www.misfitsmarket.com and use code GROCERY15. That's promo code GROCERY15 for $15 off your first order. Misfits Market is not available in all 50 states. For more info, visit misfitsmarket.com.
So I was going to ask you how this would inform how we treat bowel issues. I think you just answered that, but something kind of a little deeper. I saw in your bio that you're researching things also like brain stimulation.
Right.
So what can you tell us about that? Because that sounds like
Sure.
new and different and exciting.
I think there's a lot of interest, and I want to keep the conversation, if we can, toward MS. Before I get into kind of brain stimulation, why does it matter what I just brought up? So multiple sclerosis is a central nervous system disorder. And it can be not just white matter. There's a lot of appreciation that it's also, could affect the cortex or very subtle ways. So any disruption of some of the nerve connections that we know to be present, not just for the motor system, which has received, our muscle movements, which has received probably most of the attention, but knowing the map of what areas are involved in organ control puts a little bit more concept to how MS could affect organ dysfunction. It could be affecting certain pathways over others, and knowing where those pathways are is really important. So,
understanding that then informs treatment.
Right, exactly. So where could you influence? Now, MS is an interesting disorder as a kind of neuroinflammatory disorder, and it may be more widespread than one spot. But it's always been hard to interpret. Your listeners may have had an MRI or many of their head, and a radiologist will say something like, no change in stable white matter disease, or the plaques are about the same size, or but they never really comment on where they are. I mean, they might, but knowing what areas are more likely to affect certain functions is really important to interpret that map. And so, clinical medicine is kind of operating at some level here, but we just, from a research standpoint, I mean, we know a little bit more. So I think, that might be a way to kind of put together things, or at least predict symptoms or which ones might get better. So brain stimulation, I mean, there are many different ways to do this. There's an interesting technique called transcranial magnetic stimulation. So this is basically using a rapidly delivered electrical current in like a little contraption that gets placed very close to the head, and that makes a magnetic field change. And you can actually stimulate, because of that magnetic field change, the surface of the brain. Which is amazing. Yeah.
I'm picturing Frankenstein.
It is a little crazy, right? So these aren't two dope on the sides. But there are techniques that kind of look like that direct electrical stimulation, but this is magnetic stimulation. It's been FDA approved as a treatment for depression. When the thing is, this can be targeted to different areas of the brain very precisely. And so, where would you? I mean, there has to be a way to use this to influence the gut, right? And so you need a map, and so that's why the mapping is so critical, because it's
if this then that,
right?
Yeah. Got it.
I mean, I think I've tried to set out hopefully people will tell NIH to give me money. No, I'm just kidding.
Yeah.
I have grants that basically give that logic, and I think it makes sense that it will work or do something. But we don't know. So that's what we're in the very early phases of trying.
Well, and you say early stages. So can you translate that into time? How long until you could imagine that would be something that we could be looking for?
Oh, yeah, that's always such a, it's.
I know.
I think
I won't hold you to it, by the way.
Well, it's like when a scientist says, in 5 years, you multiply it by whatever. Yeah. So, I mean, I think, we're not there yet. But I think, within the next, I think, 10 years, I think there's some plausible way to kind of get there. I'm optimistic because there are other ways of doing this. So your listeners may have heard of something called a vagal stimulator or vagus nerve stimulator. It doesn't have to be at the brain level. So one can get at these nerves in the periphery too. And there's a lot of interest in using the vagus nerve at the neck, which it runs down, kind of very close to our carotid artery, which is you can feel your pulse right there. So it's, anatomically, you have a left and a right vagus nerve. There are devices that can actually stimulate at the neck externally. The vagus nerve is actually used for migraines, which is interesting. So the vagus nerve has been implicated in all sorts of functions, not just the GI tract's function, immunologic function. It actually has an anti-inflammatory arm of it. It talks to the immune system. And could MS be, it's an immune system disorder? Yeah. Could that be a target? I think there's so many interesting opportunities to think about non-drug ways of influencing the disorder that I'm not doing, but somebody could.
Yeah. Well, you speak of sort of brain-based therapies, and that's so different from what we are used to. Certainly, it's heretofore been a lot of drug-based or lifestyle-based or something like that. But this sounds pretty exciting. This is kind of...
Well, thank you. I mean, I'm not doing all of that research. I'm doing some of it, but I think it's important for your listeners to kind of have some concept that there is a very strong movement in research and medicine, modern medical science right now, to try to exploit an understanding of the neural regulation of organs as the basis for a treatment for chronic organ dysfunction. So, for example, high blood pressure. I mean, to the degree that it matters what kind of nerve function goes to your kidneys, maybe those nerves, if they're regulated a different way, you could have a different blood pressure. Your kidneys are very important for blood pressure. So maybe you don't need a diuretic. Maybe it's actually something to do with the nerve function. So every branch of medicine right now has it's even called electroceuticals, right? So pharmaceuticals would be drugs. Cool. Electroceuticals would be some kind of nerve-based therapy for a wide range of disorders. So MS, I think, is certainly right in there, and it could be a possible target. Yeah.
That's so cool. I love this. I love the promise of possibility of science. I love that. Yeah. It gives us a lot of hope. That's why I love interviewing people like you that can, maybe it's not available right now, but I feel like saying, hang in there because it's coming, Yeah.
Well, it's exciting to be in the field. Yeah.
Yeah.
So, yeah.
I was going to say, so how do you counsel your patients to deal with bowel issues? So I made reference to, there's a lot of, drugs that sometimes work, sometimes don't. I know food, exercise, prunes, enemas, anything new in your arsenal, or is this... We haven't gotten there yet.
Well, you listed a number of things. So I think it depends on kind of what the problem is,
sure.
Right? So I think let's, because I'm sure your listeners want to hear a little bit of clinical application. So, if we think about constipation, for example, and fecal incontinence, let's focus on those issues. So they are not mutually exclusive. There are some people who actually have constipation and also fecal incontinence, which is really a tough kind of double win. And how could that be? So there could be issues that MS affects the gut in terms of the colon's speed of contraction, right? So its transit, or it could be slow, and that really dictates kind of what stool looks like. Unfortunately, we have to talk about it a little bit.
Yeah.
The colon's job is to resorb fluid, and if material's in the colon for a longer period of time, it'll be physically firmer or harder. So anything that can speed up the colon or lead to a more liquidy environment could influence stool form. So if someone is constipated, it makes sense to do something like fiber. I'm sure many people have tried that, right? So the question is, that might be enough for some people, but not everybody. And prunes, how would that even work, right? I mean, the prunes are essentially a laxative in the sense that it contains a sugar, sorbitol, that our body can't absorb very well. So it acts essentially like a medication called Miralax, which many people have probably heard about. So prunes are kind of like a natural Miralax, right? And again, that may work for some people, but beyond the over-the-counter kind of laxatives, one can actually medically stimulate the colon to contract a little bit more. So there are medications that, probably a gastroenterologist feels more comfortable giving, more perhaps than a primary care physician or a neurologist, but to me are kind of in our arsenal that we use all the time. So one can give a medication that boosts the vagus nerve's communication to the gut, for example, or supplants the nerve, but kind of targets the receptor for the vagus nerve. So that's one approach. There's another medication called prucalopride, which was recently FDA approved in the United States a couple of years ago, that works on some of the enteric nerves that are in the gut itself and use serotonin receptors. And that seems to have a pro-motility agent. So there are lots of ways you can kind of stimulate the gut. But what if fecal incontinence is there? You don't want stool form to be too runny, because that's going to be a problem. And what's the problem with fecal incontinence? Weakness of those muscles. This is my way of saying the sphincter muscles, right? I always use my fists. So the anal canal. Sorry, I talk with my hands. That muscle's tone matters for the gate between what's in the rectum and what comes out, or volitionally or not. And stool form matters a lot. So you might want to actually go the other way and firm up stool. Fiber can do that, but then slowing things down might be important. So things like Imodium. So if a stool is too runny, changing stool form is probably the biggest factor to prevent fecal incontinence. So these are kind of like general interventions that I would use for almost anybody with these problems. Patients with MS just have a higher prevalence of these problems. So there's no, the things that I kind of would use in patients that I see, which I see a lot of patients with MS, really is just kind of taking the whole toolkit we have and applying it to that patient. So it's not really MS specific, but then you have
patient specific.
It's patient specific, right? Exactly. Yeah. And I think just the range of issues that MS patients kind of face is the same range of issues anyone can face. It's just skewed toward more likely to have kind of than an average person. Yeah. So does that kind of help a little bit?
Yeah, absolutely. 100%. So since we went down this path,
sure.
Can we talk about the makeup of a good stool? So I know that there is I'm trying to think of, I can't remember what it's called, but there is
Bristol stool chart.
Yes, the Bristol stool chart.
It's in your head.
And so it is. So can we talk a little bit about like what's normal? What should we look for? What's good? What's bad?
Yeah, sure. Yeah, I guess I've always struggled to kind of just do this with just verbal description. I should have brought the little chart, right? I don't have it. But so
I'll put a link in the show notes to the Bristol stool chart, by the way.
It's right on So Bristol, like UK, the city Bristol, BRISTOL. So this scale is a visual kind of analog of like, what does your stool even look like, right? And this is a 7-grade 1 through 7 scale, and 1 being, and just to go for it, I'm going to say, rabbit pellet like
bring it
hard stool, balls or hard things. If you just describe that is constipation, right? So from a clinical trial perspective, just even saying I have type 1 stool, Bristol stool, would kind of say, you have constipation.
So knowing that could save you a lot of misunderstanding.
Yeah. I mean, I think, in our clinic, we actually use that scale. So it's kind of, just because it's, it's a common language.
Yeah.
You say, patient's describing type 2 stool or whatever. Now, all the way to 7 being just a total puddle of, so, okay, I won't go beyond that. But
puddle
everything
of poop, I'll say it.
Right. Puddle of poop, right. So colonoscopy prep, like, kind of, the stuff that comes just water. But what is the perfect poop, right? And so, from a just a definitional perspective, type 3 to 5 would be like the range of normal. And that would be some things that have form, anything from, it's not really a length. It's kind of weird. I mean, it's just, the perfect poop would be, formed, one piece, all out, feel like you got it all out. And that does magically happen for some people, but not, a lot of patients with MS don't have that. Yeah. So
about
that would
40% don't.
Yeah, right. Exactly. So these issues are very common in the general population, overrepresented in MS. So that's the Bristol stool scale. Yeah.
Got it. Okay.
So what's normal is no blood, right? Just to be clear, I said what's normal, right? So this is stool form. You can't have red blood in your stool. Mucus is not unusual. So a lot of people say, I had mucus. That's okay. A little bit. So it's really down to blood, right?
Yeah.
And so no blood. Good. Yeah.
Good. Well, overall, I think it's really important that we say you should be looking.
Yeah.
Right? Check.
Because, wiping, blood, but I
take a gander.
Yeah, sure.
Make sure that things are looking like they should.
Exactly. Sure.
I think all of this is super exciting and I think hopeful, the kind of research and everything that you're doing that you shared with us today. Is there anything in your research in particular that you're really excited about? I think it's all super exciting, but...
Oh, thank you. Sure. I appreciate, first of all, thank you for having me here. It's really great to have a platform to, communicate with lots of people out there. I think, the work I kind of mentioned about the mapping really does get me very excited because it's the first kind of real visualization, not just of the where, what areas of the brain are connected to the gut, but also kind of their proportion, which I didn't really emphasize. What areas are heavily represented, which areas have a little bit of a connection. And, I think, with every different method scientifically that comes out and available to study a question, you learn a little bit more. And I think I've been very privileged to be at kind of this kind of early phase of this next way of looking at this problem. And so we published a paper last year about the stomach. I think we're going to be coming out with a few more papers in the years to come. So that gets me excited because it's really helping to just inform a question that's been around for so long. What areas of our brain control the gut? And so, and that has a lot of influence on the field. So that keeps me going. And I love patient care. And I think, we have a very close relationship with our MS group at UPMC. And that's been very gratifying to kind of codify a little bit of we don't send as many patients to them as they send to us, but that's okay. We're here to work with, and they're actually partners in our research too. So it's a very productive collaboration for patients and also from a science perspective. So,
excellent.
Yeah.
Great. Well, thanks so much for being here with me today, Dr. Levinthal. Really appreciate all this great information. And like I said, I think you gave us hope too, which is can be in short supply sometimes. So if people want to learn more about you or your research, your clinic, where should they go?
Well, right. So, I have a web presence, as a clinician, and, so if you were to even Google Levinthal, Levinthal and UPMC, you'll quickly get to my clinician page. I'm on Twitter. My handle is at Levinthal David, all one word. Not too exciting of a handle, but I
gets the job done.
Gets the job done. That's me. Those are pretty much the ways to get.
Excellent. And I'll put all that in the show notes as well. So, again, Dr. Levinthal, thank you so much for your time and for working on our behalf. We very much appreciate it.
Okay, my pleasure. Thank you for having me. This was great.
Quick shout out to Steve Woodward at podcastingeditor.com for the fantastic work on this podcast, including editing, show notes, and ingenious ideas. If you'd like help with your podcast, whether you're just starting out or an old pro, visit podcastingeditor.com and tell Steve I sent you. Thanks, everybody. I really appreciate you listening to the FUMS podcast show. Be sure to subscribe to it so you won't miss an episode. You can do that right on the website at FUMSnow.com. While you're there, sign up for the free email list so you'll be among the first to know of any new findings in MS research, new therapies and products, as well as any blog posts and podcast episodes I release. Want to chat with others in the FUMS community? Join us on Facebook at FUMS Now. Thanks again, and don't forget to talk to the stupid disease as it deserves. Tell it FUMS every day.